Okay, so here are the answers to the Math 1015 final exam review. Okay, I'm not going to talk much through this, okay, but you may need to pause the video or fast forward or rewind, whatever you need to do. I'll try to keep it short. Okay, so there's numbers 1 through 3. Okay, and I'm going to put up the rest of my page there up through number 5. Okay, and then I'll go to the other page, or my next page, number 6. Okay, so there's the graph of the 3 lines. Okay, notice in part C, we have to get y equals mx plus b, so we can subtract 6x, and then divide by -2. And make sure you divide everything by -2, so you get positive 3x and minus 6 there. Okay, so that minus 6 is coming from positive 12 divided by -2. Okay, and then I'll look at number 7 and 8. Okay, notice in number 7 there were many answers to that. To make a table of values that represent a function or not a function. In order to be a function, remember each x has only one y, or each input has only one output. Okay, so to be a function, basically your x values do not repeat themselves. In part C, to not be a function, in the table I gave, notice that x equals 2 has more than one output. Okay, so x equals 2 is 2 different answers to it, so that's not a function. To be a linear function, okay, in part D, a linear function means the slope has to be constant, so you have to have the same slope each time, or reduced to the same slope each time. Okay, so the change in y over change in x. For example, if the slope was 2 over 1, or in this case, in part E, 3 over 1, okay, that slope is the same every single time. Okay, 6 over 2 would reduce to 3 over 1, 9 over 3, 12 over 4, and so on. Okay, and then number 8, that's trying to find the intercepts and the slope. Okay, so I'll let you look at that. Okay, remember every single time to find an x-intercept, you let the y value be 0. To find a y-intercept, you let x be 0. Okay, so whatever intercept you want to find, if it's an x-intercept, you let y equal 0. For a y-intercept, you let x equal 0. Okay, basically you let the other variable equal 0, and then solve for the variable you're looking for. Okay, and then we'll go to number 9. And 10. Okay, so there's 9 and 10. Okay, you don't need number 14 yet. Okay, and then there's 11 and 12 on the left-hand side there. And then there's 13 and 14. And then number 15 is there. Okay, so 15 was factoring. Okay, notice the first several have a greatest common factor. Okay, part C is one if you look at, you notice how when you look at 12a squared times b, negative 8ab and 4a, you can divide each of them by a 4. The 12, negative 8, and 4 divides by 4. And then a squared b, you can take an a out. ab, you can take an a. And a, you can take an a. So that means 4a is your greatest common factor. And then we're left with the parentheses there. Okay, similar in part D, you have the greatest common factor of 4y. Okay, so that was 15. Let's see, number 16. I'm trying to find. I just misplaced all my papers here. Up here it is. Okay, here's number 16. Okay, these were solving equations. Okay, so you notice each of those factors. Okay, so you have to pay attention to directions. When I say factor, it means you ended the parentheses. Okay, and that's in the second step. That's factored form. And then solving is when you get x equals some number or numbers at the end. Okay, so those all factor nicely. Notice that part D is greatest common factor. You can bring a 2x out. Okay, the other ones were unfoil. Okay, and then there's 17. Okay, the first couple are the types we didn't concentrate on in class. But if you look at part C, 3x squared equals 24. That's where you do the square root. Okay, don't forget the plus or minus, or else you're going to miss a lot of points. Okay, over half the points if you don't put the plus or minus there, because that's really the gist of the whole problem. And then notice in part E, we get x squared equals negative 9, which means x equals plus or minus the square root of negative 9. So there's no real solution for that. Okay, and the other three, A, B, and D, okay, notice we have, if I just look at A, y plus 3, that quantity squared. Well, if you wanted to, you could do y plus 3 times y plus 3 and FOIL that out and then subtract 64 from each side. But this is set up where you could actually square root this. Because if you take something squared equals 64, well, what squared is 64? Negative 8 or positive 8. So you set whatever is inside the parentheses equal to negative 8 and positive 8. Okay, that's a method we didn't really focus on in class. So if you had something that looked like this, I would probably expect that you would square it out, so multiply it by itself and then get it equal to 0 to solve it. Okay, number 18, okay, that's using the quadratic formula. I will give you the quadratic formula on the exam. I'll either write it on the board or if I expect you to know it, then I'll tell you to raise your hand to make sure it's correct before you go on. Okay, so you don't need to memorize it necessarily. Okay, so that was up to number 18. And then okay, here's number 19. And then number 20. Okay, and in part D, you can find the axis of symmetry by doing by either adding your solutions to any of the first few questions in A and B, and then dividing by 2, or you can do the x equals negative b over 2a, and you would get 13.5 no matter what, and then plug that into your function to find the actual height. Okay, and then number 21 and 22. Okay, so there's 21. Okay, and then 22. Okay, 23. Okay, notice in part B, okay, this is one where when you go to solve the equations, what happens is the x's totally disappear, which is always a good thing in life when your x's disappear. Okay, but notice here we get negative 21 does not equal 10. So that is not a true equation, so there's no solution for that one. If it just so happened where we ended up getting like 10 equals 10 or negative 21 equals negative 21, well, that would be a true statement, which means there would be infinite number of solutions. Okay, and this goes back to the solving systems of equations algebraically and graphically, where you either have parallel lines that never intersected, okay, that meant there was no solution, or if you drew two lines and they were the same line that you drew twice, that would be infinite number of solutions. Okay, so you need to go back and look at that stuff. Okay, the solving systems of equations. Okay, and then here's number 24. Okay, this was solving a system of equations graphically. Okay, remember that to solve a system of equations, what it means is where do they intersect, or what point or points do they have in common. Okay, so when you draw two lines, in these two cases they intersect at one point, so there's one solution. Okay, and in class I talked about how if you had a quadratic, so you had a U shape or a parabola and a line, they may intersect in 2 points, or 1 point, or no points. Okay, so again, the basic concept is the solution to a system is where they intersect, or what points do they have in common. Okay, there can be more than 1 point. Okay, and then number 25. Okay, number 25, that was a scatter plot. Okay, I didn't actually make a scatter plot. And then drawing a linear model. Okay, and then I actually chose the points 4, 80 and 9, 116. On the final exam, if I give you something like this, I will probably tell you what 2 points to use, just so I don't go crazy when I grade it and having everybody use different points. Okay, so make sure you can do a question like this, and if I specifically told you what years to use or what points to use, okay, you can still find the slope and the y-intercept and explain their meaning and answer all those questions. Okay, and then 26. Okay, this semester we did not get to domain and range. Okay, but all that domain is are the x values that are on your graph, and the range is what y values are on your graph. Okay, so when you look at this, what x values are on the graph? Well, anything between -2 and +3. So -2 less than or equal to x less than or equal to 3. And then the y values, the lowest y is -5, the highest y is +4. So the way you write the range would be y is larger than -5, but less than or equal to +4. Okay, 27 was evaluating functions. Okay, so that's here. Okay, and then the last few questions. Let's see, 28. It's here somewhere. Okay, 28 is a quadratic function. The first one, f of 6, you plug 6 in for the t value. And then part C, if f of t equals 190, you set your equation equal to 190 and solve it. You use a quadratic formula on this one, and you get answers of 2.9 and 12. And then the axis of symmetry, you do t equals negative b over 2a, which will give you 7.45. Plug that into your function to get the y value, and that's your vertex. Okay, so the vertex is always the point. And in this case, it's a minimum. Okay, so during 2007, so when t is 7, now if we used 8, if you said during 2008, I would accept that. The number of viewers reach its minimum of 86.4875 thousand viewers. We know it's a minimum because the original equation was a positive 5t squared, so the a value was positive, so it opens upward. Okay, so we know that we have a minimum value for the vertex. And then in part E, 1 million viewers is 1,000,000. So you set 1,000 equal to your 5t squared minus 74.5t plus 364, and solve that, and you end up with, it's hard to see there, but negative 6.07 and 20.97. So that means in 1994 and 2021. Okay, those are the 2 years when you would expect they had 1 million viewers. Okay, and then the final 2, we're looking at function notation. Okay, so those are the answers there. Okay, so that's it. It was a little longer than I expected, about 17 minutes. But again, if you need to go back and look at anything else, or if you have questions, if I think if you have a typo or somewhere, let me know. Other than that, good luck on your exam, and we'll see you on exam day.